All right, in this video, we are going to continue our discussion of section 4.4, percents in compounding. Fun part is we're not yet at the point where we are going to start the compounding. We're still looking at incorporating change. We'll start looking at the difference between argument and image and a little bit with percent composition. And let's start here. For this particular problem, pay attention to how the standard for percent changes even in the middle of the problem. Sales of widgets went up 40% in 2014 and down in 2015. What was the overall change? It's sometimes common for students to look at it and say, well, if I went up 40 and then down 20, it gives me a 20% change.
No.
And that's wrong. In this instance, taking 40 plus 40 and minus 20, that is based on a single standard. If we had said it went up 40% from 2013 and down 20% from 2013, if we were basing it off the same standard, we could do this. But it's not. When we are looking at it and we say we went up 140%, we went up 40%, how would we express that with multiplication? Yes, that's 1.4. A 40% increase is 1.4. Well, when we talk about going down in 2015, that's not based on the things from before, it's based on the most recent year. We're now changing the standard. Well, if we are going down 20%, how would we express that as a decimal? Yes, if we go down 20%, it means we're keeping 80%, and so that's 0.8. We can keep track of changes stacking on top of changes, percents on top of percents, by simply multiplying them in their stages. That's our argument and image that we're paying attention to. And so we can put these two things together and say, what's 1.4 times 0.8? This yields an overall combined change of 1.12, or we know that this is 112% of the original. Well, 12%, 112% of is the same thing as a 12% increase. All right, let's consider this next example. Which is a better investment? Purchased some stocks, which went up 13.5%, and then you sold them for a 12% commission, or antiques, which went up 35% and were sold for a 23% commission. Well, I'd like to make an observation here. Please notice 13.5 is like saying we've added 13.5% in value. But then we also have to pay a 1.5% commission, so it's common for students to say, well, that's a 12% increase. Well, if you sold it for a 12% increase, hooray, yay, we're happy, you made some money. Well, now consider antiques. If you went up 35% and sold it for a 23% commission, once again, you'd look at that and say, 35 subtract 23 is another 12%. So if we look at addition or subtraction, on the surface it looks like they're the same. Unfortunately, this is still completely useless because they are different standards. The 13.5% is based on the original value of the investment. The 1.5% commission is not based on how much you put into it. It's based on the value at the end when it was sold. It's not the same standard. So we're not allowed adding or subtracting. Trying to compare 12 with 12 is completely useless. It's wrong. Instead, we have to keep track of the multiplication. If your stocks went up 13.5%, that's 1.135. If you sell them for a 1.5% commission, that means you've lost 1.5% at the end. If you lose 1.5%, it means you're keeping 98.5%. So 98.5% keeping is 0.985. In a moment, we will multiply this out and figure out the value of the investment. We have the same kind of structure for the antiques. If they went up 35%, that's 1.35. And sold at a 23% commission, that means we're keeping 77%. 77% is the decimal 0.77. Well, let's multiply both of these decimals. What do you obtain? In the red, we have 1.034. Okay, correcting that, 1.0395. And in the purple, we would get 1.11775. 975.
Oh.
7179.
117. Okay. In both of these instances, we still need to keep track of the percent change. When we subtract off the original amount of the investment, we get the change represented as a decimal. In this instance, it's approximately 11.8%. And for the antiques, when we subtract off the original amount, we get the percent change expressed in its decimal format, which is 3.95%. Thus, which one was the better investment? Stocks were. All right, let's consider this relationship now. B is 25% more than A. Of course, then that's telling us B is larger than A. So A would have to be smaller than B. If B is 25% larger than A, how much less than B is A? It's common for students to say 75%, and that's wrong. 75%, of course, would come from 100 minus 25, but the percent relationships don't work that way. If we are looking at this relationship, we would have B is 125% of A. Here's our mathematical relationship between the two. Well, if we then want to express B as or A as a percent of B, we would just move this over and obtain A is equal to 1 over 1.25 times B. Well, grab your calculator and actually divide that out. 1 divided by 1.25 is not 75. It's not 0.75. What is it? With 3 significant digits. So we've got 0.8b. And thus what we get is that B is 80% of A, not 75%. When you start working with percents, please remember the reciprocal fact. If we were to take this as a fraction, if B is 5/4 of A, well, to change it and go the other way, we wind up having the reciprocal. 4/5 of B is A. That's what this problem is doing for us right now. And it comes just from your basic pre-algebra, but it's a really common mistake. You should avoid it. Okay, consider this one. An increase of 30% was followed by a decrease of 30%. What's the overall effect? Think of it this way. You're walking around and you find $20. Let's say, to provide some context for what's going on, let's say you're walking around right now and you have $100. And then you gain and find $20. Well, hooray, now you're up to 120. Because you have a hole in your pocket, you're dumb and you lose your $20 and it falls out. Right now, you're back where you began and you're at 100%. For $100. You're like, oh, cool. In this instance, if you gained $20, you've gained 20%. But when you lose the $20, that's losing $20 out of 120. 20 out of 120 is 17%. Did you wind up making money? You're like, hey, I'm still at 3%. I'm still okay. No, this is kind of the problem that we're looking at. When you're starting to think of percents, adding and subtracting percents doesn't work because of the change in standard. Just because raw numbers work with adding and subtracting, percents don't. Anytime you're working with percents, your basic intuition should be multiplication and division, keeping track of it that way. So when we gain 30% and lose 30%, we have 1.3 times 0.7. It's not something that just balances out and turns back into the original. This is 0.91. So the overall effect is that we've lost 9%. All right, here is a tougher example. It'll involve a little bit more algebra, a little bit tougher to set up. You're going to invest $100,000 in two funds because, you just have $100,000 laying in your sock drawer. The first fund, 85% of it is in stocks. Fund B, 45% of the money you put in Fund B will go towards the stock market. Now, your plan is to invest a total of 70% in stocks. Neither Fund A will give you 70% by itself, nor Fund B will give you 70% by itself. So what is the correct ratio? How much do you put in A to make certain that you get the total of 70% that you want? Well, to start off with this, we need to have a variable. So I'm going to define X is the amount of money that you put in Fund A. Because, frankly, I want to know what's going into Fund A, so I'm going to make that my variable. Well, if I've put X in Fund A, how much money is there in Fund B? For instance, if I put $20,000 in Fund A, how much is in Fund B? 80,000. How'd you get to 80,000? Quite simply, you subtract it off from 100,000. That's what we'll do here. If we have X in Fund A, we can take 100,000 and subtract it off. And that will give us however much is left in Fund B. Now, to continue these relationships, we would have 85% of the money, so 85% of A, so 0.85 of A. This will tell us the amount of money that we put in the stock market based on Fund A. We can add in the money that we've put into Fund B stock market. That's 45% of Fund B. So 100,000 minus X. And these two things have told us how much money we've put in Fund A for the stock market, how much money for Fund B is in the stock market, and how much money did we want overall. 70%. So that's 70% of the original $100,000. And we've built an equation now. You may note this was looking at the dollar amount that we put in A plus the dollar amount we put in B will match the dollar amount we've put in the overall combined. And we were changing it from dollar amount to percent in the stock market amount. Well, now that we've got this, let's go solve it. This, of course, is 0.85x. I don't know why it's writing in blue or in black. When we distribute across, 45% of 100,000 is 45,000. And 70% of 100,000 is $70,000. When we subtract over the 45,000 and combine our like terms, we get 0.40x is equal to 25,000. Thus, we can divide by 0.4, which comes out to $62,500. Laying around in your sock drawer. The diameter of pizza A is 25% greater than the diameter of pizza B. How much greater is the area? Well, pizza A is pi times radius squared. Pizza B will have area pi times radius squared, but of course it's not the same size area. Or I'm sorry, it's not the same size radius. Well, if pizza A has a diameter that's 25% larger than the diameter of pizza B, the radius is also going to be 25% larger. So when we're putting these pieces in, please consider this. We'd have the radius for pizza B, the radius for pizza A. This is telling us the radius of pizza A is 25% greater than the radius of pizza B. Does this make sense, guys? Well, we can make this substitution then and plug it in for the radius of pizza A, getting pi times 1.25 times radius B squared. When we expand this then, we'd have pi times radius b squared times 1.25 squared, which we will notice that's 1.5625 times pi times of b squared. Well, right here's our key feature. This is 56.25% larger than the area of pizza B. And so here we go. It's 56.25% larger. All right. That finishes up all the pieces that we had for today. In our next video, we will examine the role that percents play in money and compounding.